Understand the question first. There is a circle here with the radius of 6 cm. So this will be 6 cm as well, because this is part of the radius. Tangent from x touches the circle at A, so XA is a tangent. Tangent meet radius, so we have a 90 degree here. So we have a right angle triangle here. So the first question will be, show that angle AOB approximately is 1.0.3 radian. Since you have a right angle triangle, so we make full use of this right angle triangle. Okay, if you have a look on this right angle triangle, we do know about the length. (10 cm) and 6 cm. This is the angle that you want to show, angle AOB. The answer should be 1.03. Right angle triangle, you can utilize SOHCAHTOA, trigonometric ratio. So this is your opposite side, this is the adjacent side, this is the hypotenuse. We are using OA. Tan theta equals to O over A. Hence, theta will be tan inverse 10 over 6. So the answer will be 1.03 radian. 1.03, okay, 3038, because it's approximately to 1.03. That's why I give it more accuracy. Then I will say that it's very close to 1.03 radian. So that is how we solve the first question. Second question, find the perimeter of the shaded region. So this is the shaded region. The perimeter will be here, here, and also here. 3 different parts. So 10 cm is given. How about arc AB? Arc AB can be found by using the formula of r theta. Radius is 6. Theta here is 1.03. So what do we have? We have 6.18. So the length here will be 6.18. The last one, XB. Okay, tan 6. You can find the length of OX, right? Pythagoras theorem. So OX equals to 10 square plus 6 square with a square root. (11.662) minus 6. 11.662 is the whole area, the whole size of the length. So OB is 6, XP is 5.662 when you minus it. So the perimeter of the shaded region would be 10 plus 6.18, the arc, and also XB. Final answer, you can round it off to 3 sig fig, 21.8 cm. So usually what we do is the final answer, if it's non-exact, we round it off to 3 sig fig. But if this is not your final answer, you always need to round it off to more accuracy. Okay, give it more significant figures. In this case, I give 5 significant figure. I correct it to 5 significant figure. The last one, find the area of the shaded region. Okay, in order to find the area of shaded region, I will have the area of triangle minus the area of sector. That will be the shaded region, right? So area of triangle is, since this is a right angle, I can go for 1 over 2 multiply with the height and the base, area of triangle, minus area of sector, r square, theta. So the height of the triangle will be 6, the base is 10, radius of a circle 6 as well, and the theta 1.03. Quite straightforward, right? (11.46 cm square). That will be the answer for question 1. We have a garden in the form of a sector of a circle. So this is a sector of a circle, and this is a garden. Sector of a circle meaning to say this should be the full circle, this should be the center. But now, instead of having the full circle, we are just having a sector, a part of the circle as a garden. So this is the garden. So in this sector, with the center O, there's another circle within the sector. That is the question about. And this is the part where we plant the roses. Okay, so this is a garden. This is the part we plant the roses. Look at the first question. This is the radius of the sector. This is the angle of the sector. The first question is to show capital R equals to small letter r. Small letter r should be the radius of a circle. Equals to, okay, sine theta. Why there is a sine theta? How come there's a sine theta? Whenever there's a sine theta, most likely there will be a SOHCAHTOA. And why is that a SOHCAHTOA? Because there's a right angle triangle. So how do you draw a right angle triangle over here? Think about that. Radius is needed. So let's say I have a center of a circle and I draw a radius. This is a radius, right? So I label as R. What happens when I have radius and then I have a tangent over here? It forms a 90 degree. There you go. So this is a right angle triangle. How do you form a right angle triangle? Why do we need to have a right angle triangle? Because there's a SOHCAHTOA here. Therefore, if you think about that, visualize it, this is your right angle triangle. Right? So if I extract this right angle triangle, this is how it looks like. This is the radius. And what is the angle here? It will split equally to theta. 2 theta, right? Now it's just theta. Okay, what else do you know? And yep, that's a right angle triangle. But knowing this is not enough for you to show this. If you look at this, you need to have another equation connecting the small letter r and capital R. So how? So this is the capital R. This should be your capital R as well, right? Okay, if I connect it like this, this will be my small radius x, and this one I will have to give it with another unknown. Use any unknown that you want. Okay, in this case I use x. So you can see that this is capital R. This is also capital R. So I can say that capital R is the same length as small letter r plus x. And why is there an x there? Because this x can be used as x over here as well. So you can label this as x as well. So you have equation 1, you can form another equation 2 from here. You must have 2 equations in order to show this. So in order to connect it, r and x with theta, you know it well, this is your O, this is your H, this is your A. So because when I have a pick on this one, sine theta, so definitely we're using sine theta. So sine theta equals to OH R over X. Very close to this already. But if you pay attention to this formula, the only unknown that involved is small letter I and capital R, no more X. What happened to the X? Because X has been substituted or eliminated. So X must be the subject. You must express X subject and then you change it with some other unknown. So this is the best way. So I express X as the subject, capital R minus small letter r. Whenever I see this, I sub here. So I have sine theta equals to R over capital R minus small letter r. Very close to what you want already. Capital R is a subject. So capital R is here, rearrange it. Once you rearrange it, you can swap between these two. Capital R minus small letter r equals to R over sine theta. Capital R equals to R over sine theta plus R. Not the final step. Look, it's a bit similar. So you take out R, you factorize it. There you go. You have 1 over sine theta plus 1. So you have shown it successfully. Okay, that's how you show for 1A, 2A. Quite tough these questions. Now if you have a look on question B, given that theta is 30 degrees, calculate the fraction of the garden that is planted with roses. Basically, you're comparing the area of roses over area of the whole garden. That is the fraction. Okay, definitely you'll be using this one later on, I think. Okay, now I'll allow it off already. Let's start with the area of the rose. Area of roses is a circle, so I can go for pi r square. Pi r, oh, I don't know the r yet, so I need to figure out the r first. Okay. Area of sector, the whole garden, the bigger circle. If I go for 1 over 2 pi square theta, this is in radian, this is in degree. When you compare, it's not going to be beautiful. The fraction is not going to be beautiful. So I'll be using the max formula. The max formula will be pi r square times theta over 360. In this way, it will be more beautiful when you have to compare and convert it into fractions. Okay, what we know is only this information. Theta is 30 degrees. So we can sub in here, right? Since capital R equals to small letter r, 1 plus 1 over sine 30. See what we have. So theta is 30, sine 30 is 0.5, right? Okay, you can calculate this with your calculator. Better check your calculator, is it better that way? Make sure your calculator is in degree mode for the angle input. What do you get? You can try first. So you get 3 here, right? Or this small letter r. So you get the idea of capital R equals to 3R. Then everything is clear. Now you can just sub the capital R with small letter r, right? I can sub R, this one, with 3R. So I have pi bracket 3R square. And then what is the angle here? Or if this is 30 for theta, 2 theta, 60 lah. 2 theta with 60. Okay, so this one is pi r square. Whereas this one is 9 times 1 over 6. So 3 over 2 pi r square, right? I keep in terms of pi, so to make comparison easier. Okay, now fraction of the garden planted with the roses. So roses how many? So roses is pi r squared. So pi r squared, this is the area of roses, over 3 over 2 pi r squared, that is the whole garden. So this is a fraction, simplify it, cut off everything, so there's a 1 here. 1 divided by 3 over 2, the final answer should be 2 over 3, that is the final answer. Okay, so therefore we have to use this formula, max formula. We cannot use 1 over 2 r squared theta in radian, then your answer will not be as beautiful. So that's part 2 lah. Now we go for part 3. R equals to 15, okay. Calculate the 1 decimal fencing inquire the perimeter of shaded region. Okay, perimeter of shaded region. So we have to find the length here, and the length here should be the same. And then also the length over here, the arc, right? Okay, let's figure out the arc first. Maybe labeling it is better. No need, right? Okay, the arc here. Just now, what is the degree here? Just now the degree is given, right? Okay, this is 60 degree, 90, 90 is a kite. So 60 here, 120 here. Right, 120 here. So 120, let me deal with the arc. Okay, the arc, part of the shaded region, right? This arc. Okay, I use max formula since it's in degree. So I have 2 pi r. Oh, I don't know my r. Okay, my small letter r. 2 pi r equals to. Oh, but just now I know already. Just now you see, that's how I have capital R equals to 3r, right? And then now r is 15. So meaning to say small letter r should be 5. So I know everything already. Okay, so 2 pi r I can write as 2 pi 5 times theta over 360. 60 here, because it's 30 degree for theta. 2 theta 60. Supplementary opposite angle for a kite, so it's 120 degree. Okay, let's see what we have. In terms of pi, in terms of pi first lah, okay. Actually no needs, 1 decimal places. Okay, you can just put everything into calculator, no need in terms of pi. 2 pi r times 1 over 3, 10 over 3 pi, that is the arc. So you have the arc now. You need to figure out this part. These two are the same, since it's a kite. Because when 2 tangent meet, you have a kite, right? Okay. Right angle triangle. Because you know this is 5, right? Okay, good. Right angle triangle. So right angle triangle that we built just now, r is 5. So now you're finding the length here. Let's call it y lah. Here, y. So this is y, and then theta is 30. Therefore, tan 30 equals to 5 over y equals to 5 over tan 30. Then your answer will be 8.660. Okay, now we can find everything already. Okay, perimeter of the shaded region. So this is 10 over 3 pi. This is 8.66, this is 8.66. This is the perimeter of the shaded region. So the perimeter of the shaded region will be 10.3 pi plus 8.66 times 2. Your final answer should be right round it off lah, 27.8 cm. 1 decimal places. Okay, 27.8 cm. That's the final answer. Okay, that is for question number 2. We have a right angle triangle with a circle. Both triangle and circle share the same part of area of a sector. First question, find the length of arc AB. We have to find the length of arc AB. The formula will be r theta. You need to know the value of r here. You need to know the value of the theta here. Since this is a right angle triangle, you can either go for Staccato or Pythagoras theorem. I think I will just go for Pythagoras theorem. It's easier that way. So think of it as a Pythagoras theorem. A square plus b square equals to c square. C must be the longest one, so this is a C, R plus 7. And then A could be 5 square, and then B could be 6 plus R square. Because this is 5, 6 plus R, and 7 plus R. So this is how you fill in. Okay, from here, let's find the value of R. Expand it, simplify it, collect the like terms. 14R minus 12R, so I have 2R here. 25 plus 36, 61, minus 49, 12. So R equals to 6. So R is 6 cm. So this is 6, this is 6. Okay, once we know the value of R, we can find the angle here. Let's label as theta. We are using Staccato to find the angle of it. So draw the right angle triangle for better visualizations. This is 5, and this is 6 plus R, 6 plus 6, 12 cm. So this is 13. Theta. You can use any of either saw, car, or tau, because you know all the value here. Okay, so in my case, I go for 10. 10 theta equals to 5 over 12. So what is the value of a theta? You can change the radian mode. Sorry. So that it shows you the answer in radians straight away. Oh, it should be 5 when you round it off. 0.395 radian. Okay, you have the radius and the radian now. You can find the arc AB, right? R theta, R theta. So the final answer, 2.37 cm for the length of arc of AB. Okay, now we have a look on second question, the area of the shaded region. The area of the shaded region, the idea is very clear. You have the area of triangle minus the area of sector. Very straightforward lah. Area of triangle, since this is a right angle, 5 and 12, so height and base, minus r square theta. Okay, just put everything into it, right? Your final answer, you can try first. 22.89 cm square. So that is question number 3. Question number 4. We have a sector of a circle. C is the midpoint of OA. The arc of AB is 19.2 cm. The radius of a sector is 16 cm. These two are parallel. These are perpendicular. First question, find angle AOB in radian. So since it's a sector, angle AOB, radius and arc is given. So very straightforward. Arc equals to r theta. Arc now it is 19.2. 19.2 equals to 16, the radius. So theta, 19.2 divided by 16. 1.2 is the radian of the angle. So the angle here should be 1.2 radian. Second question. Find the length of DE. This is the length of DE. It's almost impossible you can find the length here because there's nothing you can use. 16 here, 16 here, radian here. So in order to find length of DE, you need to draw a line here. Because this is parallel, right? Perpendicular. DE should be same as here, should be same as here, should be same as here. Here also DE, right? So as long as you find the length of this red color line, that is DE already. And this is 90 degree. 16, so this will be 8. So this is a right angle triangle kind of thing. Right angle triangle. You need to find this, right? So label as X. This is DE lah. Same as DE. This one is half of the radius. So that will be 8 cm. And this one is 1.2 radian. Okay, more than enough already. This is your O. This is your H. This is your A. So kato. So sine 1.2 radian should be the same as X over 8. So X will be 8 times sine 1.2 radian. Make sure your answer, your angle input is in radian. Huh? So you should get 7.46 cm, 36 feet. So DE is 7.46 cm. Okay. Question 3. Show that length angle DOE is approximately 0.8 DOE. Need to redraw lah. DOE. So just look at this triangle lah, huh? So now it's just about DOE. Anything that you know about the length of this triangle? You do, right? You have just figured out. The length of DE is 7.46. Do you know OE? No, you don't know. You don't know the length of OE. Your objective is to find the theta here. Huh? Okay, I don't want to use theta anymore. I use Y. Don't want to confuse you. OE, I don't know. So only one length is not possible to find the angle. Do we know the length here? OD. By right, you should know. What is the length of OD? OD should be same as OA, should be same as OB, right? This is the radius of a sector. Therefore, OD is 16. Okay, you can solve already. So to find angle DOE, which is Y, this is your O, this is your H. So sine Y equals to 7.46 over 16 radian. So make sure your angle input is in radian also. The answer must be in radian. Oops, wrong input. So you should get 0.848505 approximately. Approximately meaning you don't give the answer straight away. You give like this first. You write like this: 485.047, and then it's very close to 485 radian. This is for question 3. Approximately. Find the area of the shaded region. Okay, I think we can still use the line here. If you want to find the area of the shaded region, we just have the area of sector minus the area of triangle. Okay, so what is the length just now? 7.46. Okay, let's try area of sector first. Area of sector, R square. R is 16. Do we know the theta here? Yes. 0.485 area of sector minus area of triangle, the height, the base, or you can find the base here, or you can find the angle here, or there are two ways. You can go for 1/2 height and base, meaning you need to find the length of OE, or you can use 1/2 AB sine C, but you need to find the angle here. Okay, I use AB sine C. So if I use AB sine C, I have to take these two as AB included angle in between. So 16 is my A, 7.46 is my B, sine C. How do I know the angle here? This is 0.8485, right? This is 90 degree, right? Okay, so you figure out 180 degree. 180 is pi in radian. Pi minus 0.8485 minus pi over 2, because this is 90 degree. This is 180 minus 0.848, this is 0.485, and this is pi over 2. Okay, because I want to find the angle here. Yeah. So let's see what is the answer. 1/2 times 16 squared times 0.485 minus 1/2 times 16 times 4.47.46 times sine bracket pi minus 0.485 minus pi over 2 close bracket. Final answer 9.28. Okay, I'll repeat one more time. What is this? This is 180 degree for the sum of interior angle of triangle minus the angle here minus the angle here. Then you have the angle here. This is pi minus 0.485 minus pi over 2. Okay, you must get the angle here because I'm using these two sides. This is the formula of 1/2 AB sine C. So this is about question 4. Question 5, we have an isosceles triangle, same length, same angle. So this will be 0.7 as well. Meaning you can find the angle here as well, right? Because you have 180 minus 0 0.7 minus 0 0.7. 180 is pi in radian. One point 7416. 1.7416, that's the radian of this angle. And then what else? DC is an arc for a sector. So this is a sector. This is a sector of a circle. CD is an arc with a center A. Correct to 1 decimal places the area of a shaded region. So the area of shaded region will have area of triangle minus the area of sector. So area of triangle, you can use the formula of 1 over 2 AB sine C. So your A is 20, B is 20, your angle is 1.7416 radian, minus the area of sector 1 over 2 R square, R is 20, theta 0.7, and then just put everything in calculator, correct your answer in 1 decimal places. (57.1 cm square). That's the answer for area of shaded region. Okay, now we look at the second question, perimeter of the shaded region. Perimeter, that will be the arc of CD, the length of BC, and the length of DB. Okay, this can be fine. This one is R theta. The only unknown here, that will be here lah, BD. To find BD, you must know this is 20 as well, right? Because this is sector, so this is 20 as well. You find AB minus 20, that is DB. How do you find AB? You can use cosine rule if you want. Remember, cosine rule for triangle. 20 here, or you can use sine rule if you want. 20 here, 20 here. Here is a 0.7, 0.7. This one is, or you can't find, or can, 1.7416. Okay, which one do you want to find? Cosine rule or sine rule? Sine rule lah, huh? Okay, so let's take this as x lah, huh? So I let x equals to be AB, huh? Okay, so to find AB, x over sine 1.7416 equals to 20 over sine 0.7. Everything must be in radian mode, because the angle input now is in radian. 30.6 cm. So AB, this is 30.6 minus 20, so this is 10.6 cm. Okay, so for part 2, let's find the arc CD. Arc CD is R theta, 20, 0.7. So I have 14 cm. So final answer, if I want to find perimeter, 14 plus 20 plus 10.6. 14 plus 20 plus 10.6. Final answer, 44.6 cm. That is for question 5. We have a sector, a small sector, included in a bigger sector. So there are two sectors here, smaller sector and a bigger sector sharing the same common center O. So the radius for smaller sector is 7 cm, and the angle for both sector is 4/3 radian. Okay, so what else do you need to know? Area of the shaded region, so this is 48 cm square. Find the perimeter. You see, if I want to find the perimeter of the shaded region, these 4 parts, I must figure out the radius for the bigger sector. Meaning to say I must know about all this length. And how? Make full use of area of sector. Okay, I can find the area here is given. I can also find the area here, and then I can find the radius of a bigger sector. Okay, so first, understand first. Let's find the radius, let's find the area of the smaller sector. 1/2 r squared theta. Okay, so what is the area of the smaller sector? (98.3 cm square). So this is 98/3, not 0.3, 98/3 cm square. So the total area of the sector, you have these two add up together. That will be 242/3 cm square, and that is the area of a bigger sector. And since we know the angle, we can find the radius of a bigger sector. 1/2 r square, theta is 4/3. So make r square as a subject. 242/3 divided by 4/3 divided times 2. So r square should be 121. R should be 11 cm. That's the reason why I keep it in proper fractions, so that's more beautiful in the end answers. So R is 11 cm. So the radius for a bigger sector is 11. This is 11. So this is 4 cm. This is 4 cm. This is 7 cm. So the remaining is very simple. Because the perimeter of the shaded regions, this is 4, this is 4. This is arc of a smaller circle, so smaller sector, and this arc of a bigger sector. Can do, right? You can try, you can pause the video and do first before you check the answer. Okay, so arc AB will be r theta, 7 is the r, smaller r, 4/3. (28/3), and then arc CD, 11, the radius is the bigger sector, 44/3. So 28/3, 44/3, 4 and 4, you can find the perimeter of the shaded region. That will be 28/3 plus 44/3 plus 4 plus 4. Final answer. You will get 143/6. Is it? Let me check my answer again. 28/3 plus 44/3 plus 4 plus 4. Oh, I typed wrongly. 32. So the answer should be 32 cm. So that's the answer for question 6.